Now I will introduce two new and important possibly in your circuit elements. These are the capacitors and inductor. Okay. Unlike resistors, which dissipate energy, as we have learned from our discussion, now the capacitors and inductors actually do not dissipate energy but store energy, which can be retrieved in the circuit at a later time. That is why they are called the storage elements. Yun ang tawag sa kanila, storage elements. Okay, yung mga capacitors and inductors natin. Capacitor is actually a positive element designed to store energy in its electric field. Common use of capacitors are in electronics, communications, computers, power systems. Example, they are used in tuning circuits of radio receivers and some memory elements in computer system. So, ito yung mga tsura ng capacitor kapag tinignan nyo yung mga IC boards nyo, yung mga integrated circuits sa mga equipments, appliance, etc. The typical representation of a capacitor is like this. Like this in figure 6.1, we have two metal plates, parallel two metal plates separated by a dielectric material with certain permittivity. We will learn about this permittivity on the latter part of our discussion. So a capacitor is also, okay, it consists of two conducting plates separated by an insulator, yung sinasabi ko kaninang dielectric material. Now, what is the behavior of the capacitor in a circuit? When we applied voltage, as you can see in this figure, ito, tingnan niyo yung figure nito. When we applied voltage across a capacitor, the source V, so anong mangyayari? The source V deposits a positive charge on one plate and a negative charge on the other plate. So the capacitor is said to be storing the electric charge. The amount, okay, the amount of charge represented by Q, ito yon, is directly proportional to the voltage applied across the capacitor. So if Q is directly proportional to the applied voltage, so para mapalitan itong proportionality sign natin, we should apply a constant. Ano yung constant natin na yon? So, the constant is actually the C. Yung C natin, C is the capacitance. Yung tawag natin. May resistance, may capacitance. Okay. The constant of proportionality in the equation is the capacitance, which is measured in farad. Okay, capital letter F, named after Michael Faraday. Okay, so 1 farad, okay, kung aayusin natin to, Q is equal to CV, so C, okay, divide both sides by V, or 1 over V, cancel ito, that is C, Q over V. 1 farad, ito, 1 farad is equal to 1 coulomb per volt. Ayan. So, it is actually the ratio. Okay, the ratio of the charge Q on a plate of a capacitor to the voltage difference between the two plates, which is measured in farad. Okay, take note. Although C is equivalent, or the ratio, okay, ratio siya nung Q over V natin, it does not mean na yung capacitance ay dependent siya sa Q or V. Parang yung ating resistance, yung ating Ohm's law. Yung Ohm's law natin states that V is equal to IR. So, yung R natin is equivalent to the ratio of V over I. So, in the case of yung capacitance natin, Q, so hindi sila nagpo-follow ng Ohm's law. Iba ang usapan sa capacitor and inductor. No? Ito yung mga equations na kailangan natin to analyze circuits containing capacitors and inductors. So, sa Ohm's law, ito yung equivalent. But how about sa capacitance or sa capacitor? So, Q is equal to CV. So, C is equal, or actually, the ratio of Q over V. Ayan, ayan yun. Diba? But they are not dependent, okay, dun sa ratio na yan. Kasi sa yung resistance natin, we have an equation for that it is dependent on the rho L over A, the dimension and the characteristic, yung resistivity ng ating element or kung ano mang material yon. As well as yung C natin, it does not depend on the Q and V. Okay, it depends on the physical dimension of the capacitor represented by yan, E A over D. Ayan siya. Ito. So, capacitance, okay, ano ibig sabihin nito? Directly proportional siya sa E. Yung E na to na symbol na yan, that is the permittivity of the material. Directly proportional din siya sa A. A is the surface area. Ito, surface area nung plates natin. And D, yung D naman natin is the spacing or the distance between the plates. Ayan. Okay, anong ibig sabihin yan? Kapag directly proportional. So, kapag directly proportional siya sa A, surface area of the plates, kapag larger yung area, okay, larger yung capacitance. As well as for the permittivity of the material, kapag higher permittivity, higher capacitance. Kapag indirectly proportional sa spacing or the distance between the two plates, kapag smaller yung spacing, higher yung ating capacitance. Kapag naman higher yung spacing, lower yung capacitance. So, kapag directly proportional sa permittivity sa surface area, kapag nag-increase yung dalawang ito or isa lang sa kanila, mag-increase yung capacitance. Sa indirectly proportionality of the distance between the two plates, kapag nag-increase to, bababa to. Kapag maliit ang value ng D, mataas yung value ng capacitance. So, ganun. Okay? Although C is the ratio of Q over V, which is measured in farad, that is 1 coulomb per volt, it does not mean that C depends on or dependent siya sa voltage. It actually depends on the physical characteristic represented by itong equation na to. So, tandaan nyo to, no? Okay, take note. We should note that in a positive sign convention, if V is greater than 0 and I is greater than 0, or if V is less than 0 and I is less than 0, the capacitor is being charged. Okay, if V multiplied by I is less than 0, the capacitor is less charging. Take note lang yung mga yun. Ngayon, ano ba yung kailangan pa natin? So, we have the parang corresponding equations ng Ohm's law natin sa capacitor, no? Yung current value ng current equation natin in a capacitor and the capacitance equation, meron na tayo. So, now, ano yung mga kailangan natin? Ang kailangan natin are actually the IV relationship ng capacitor and as well as yung VI. So, current voltage relationship ng capacitor, voltage current relationship ng capacitor, the power equation, and the energy equation or W pala. Yan. Kailangan nating malaman yung mga yan. So, umpisahan natin. To obtain the current voltage relationship of capacitor, we integrate, or we differentiate both sides. We know that I is equal to dQ over dt, right? Ano na yung meron tayong equation? That Q is equal to C times V. Okay. So, if I is dQ over dt, dati na natin equation yan. So, kung papalitan natin, ito na kasi equation natin. Kung papalitan natin yung ating Q, okay, ng CV, so palitan natin ito ng, okay, dito ko na lang lalagay sa side. So, I, D, what is Q? Q is CV over dt. And C, yung capacitance natin ay constant yan. Okay. So, as we substitute Q and I is equal to dQ over dt, we will get I is equal to dc of V over dt. Since C is the capacitance of the material or yung ating element sa circuit, it is a constant value. So, lilipat natin siya sa side na to. C, that is dV over dt. Ayan. So, this is the current voltage relationship of the capacitor. So, kailangan nating tandaan yung ating equation. And this relationship is illustrated in this figure. As you can see, it is a straight line with a slope C. Kung maalala nyo yung ating equation for linear, yung mga straight line or line equation natin, y is equal to mx plus b. B is the y-intercept. So, ang intersection ng ating line sa axis is 0. So, y is equal to mx yan. Yung y natin, bale, that is your I. C is the slope. And x is equal to dv over dt. Kaya ang itsura niya is linear. Okay. So, sa discussion natin, or ang assumption natin for our analysis in this topic is all capacitors are linear and ideal. So, for capacitors na ganito ang kanyang graph, so they satisfies this equation. But for non-linear, yung plot nila, certainly hindi siya straight line. Although most of the capacitors are linear. Okay, so ano yung makukuha natin na conclusion dito sa equation natin ng current voltage relationship ng capacitor? So for a capacitor to carry a current, yung voltage dapat natin must vary with time. So kung ang ating capacitor ay connected sa DC source, therefore, yung DC source kasi natin, di ba? Usually, DC source ang ginagamit natin sa mga previous analysis natin. Kapag sinabi mo kasing 24 volts yan, all throughout the time, 24 volts siya. So, if the source doesn't vary with time, therefore, this is 0. And 0 multiplied by the capacitance of the material is equal to 0. So, for a capacitor to carry a current, yung hindi siya magsi-zero dito, the voltage must vary with time. So, for constant voltage, like for the DC source, wherein voltage is constant, sabi ko nga, so the current would be equal to 0.